Oftentimes, we're going to need vectors that have a length of 1 unit long. Observe these 4 vectors, v1, v2, v3, and v4. All of these vectors are pointed in different directions, but what they have in common is that their magnitudes are each 1. We call these unit vectors because their magnitudes are a single unit long. Now, there are various reasons why you would want a unit vector or a vector in some direction whose magnitude is 1, and we'll see those reasons soon. For now, we're going to talk about how we can obtain a unit vector when we have a vector of some arbitrary length. Now, let's take the two-dimensional vector 3, 4. We know that we can calculate its magnitude, and it's not 1. It's actually the square root of 3 squared plus 4 squared, and we've seen that this is the square root of 9 plus 16, which is the square root of 25, which is 5. So the magnitude of the vector 3, 4 is 5. So we see that this is not a unit vector, but let's say we'd like a vector pointed in the same exact direction with a magnitude of 1. Well, we've seen that we can scale vectors by a scalar value. And if we want the unit vector in the exact same direction as the vector 3, 4, we want to reduce that vector down to a length of 1. We do that by dividing by its magnitude. In other words, the vector that is normalized is equal to that vector divided by its own magnitude, which in this case is 5. And to divide a vector by 5, we simply need to multiply by 1 over 5. So we can take the vector v and multiply by 1/5, which, as we've seen with vector multiplication by a scalar, is simply going to result in the vector 1/5 times the x component, which is 3, and 1/5 times the y component, which is 4. This simplifies to the vector 3/5, 4/5. This is the vector v normalized down to a length of 1. This is the vector in the same direction as v, except it now has a length of 1. It's a unit vector. When we reduce a vector down to a length of 1, it's said that we normalized the vector. So the process of dividing by a vector's magnitude or multiplying by 1 over the magnitude is the process of normalizing the vector. Now, can we prove that this result has a magnitude of 1? Well, sure we can. We know how to calculate the magnitude of a vector. So the magnitude of our new vector v sub n is simply going to be the square root of x squared plus y squared. X squared is going to be 3/5 quantity squared, and y squared is 4/5 squared. Now, this might be an algebra review for you, but the way to simplify this is to square 3/5, which means the 3 and the 5 will be squared. So 3 squared is 9, 5 squared is 25, and 4/5 squared is 16 over 25. And we can add these two fractions together. The result of that addition is 9 plus 16, which is 25, all over 25. And 25 over 25 is 1 over 1, which is 1, and the square root of 1 is just 1. So we have proven that the vector 3/5, 4/5 has a length of 1. Now, the vector we started with, v, which is the vector 3, 4, we have to move 3 units in the x and 4 units in the y to draw this vector, has now been reduced to a length of 1. That's 3/5, 4/5. And that's going to be this vector with a length of 1, and it's exactly 1/5 the length of vector v, because vector v has a length of 5. And the vector we've calculated, v sub n, has a length of 1. And we've seen that we can scale a vector by a scalar, and that's going to multiply that length by the scalar. In our case, that scalar is 1/5. So we started with a vector with length 5, we multiplied that vector by 1/5, and we got a vector exactly 1/5 the length, which is 1. And that's why we can always divide a vector by its magnitude in order to obtain a unit vector in the same direction, and the process of doing this is called vector normalization. And the vector we obtain is called a unit vector because its length is 1 unit. Vector normalization is always going to be useful for us because sometimes we need a vector with a length of 1. Let's take a look at a very simple example. Now I have a character, and my character has a location in space. If I draw the vector from the origin to this character, we have a vector, we'll call it v sub c. And let's say that we have an enemy, and the vector from the origin to that enemy can be represented by v sub e, e for enemy. Now let's say that our enemy wants to move towards our character, and we want that enemy to move at a constant rate. Let's just say 1 unit per second. Well, we know that we can calculate the vector from v sub e to v sub c, right? It's going to be v sub c minus v sub e. That's going to be this vector, the vector from the enemy to the character. V from E to C. Well, if we want to move our enemy 1 unit at a time, we need to normalize this vector. And we know that we can normalize this vector by dividing by its magnitude. In other words, this vector pointing in the same direction as v sub e to c, we'll call this v sub n, can be calculated as follows. V sub n equals 1 over the magnitude of v sub e to c times the vector v sub e to c. We're going to take the vector from the enemy to the character and scale it by 1 over the length, and that's going to give us this, the unit vector from the enemy to the character. And once we calculate that, we can now move that enemy by that vector amount. So now that we know how to normalize vectors, let's get some practice.